Hello, everyone. So today I'm going to talk about the short intro to scalable machine learning pipelines with Apache Spark. And a few words about myself. I'm a senior big data engineer at Grid Dynamics company. I'm working as a big data engineer already for a few years. Also, I'm getting my second master degree at data science. And I'm actually a big fan of programming, of data processing and analysis, of data science, etc. So let's start. So today's agenda is next. First of all, we will go through some small intro to Apache Spark. Next, the part we are going to talk about the Apache Spark MLLib. So the part is related to the machine learning pipelines and machine learning algorithms in Apache Spark. The next part is actually the building scalable machine learning pipelines with Apache Spark. Next will be some short summary and a Q&A session. So I hope you will have any questions. And so give me a second. Yeah, so let's start. So today's the data pipelines looks next. So first of all, we have some data that we want to take and make some predictions, modeling, inferences from it. And first of all, the data, it can be stored in different formats and taken in different manners. It can be like historical data, it can be streaming data, data in different formats, etc. And next part, when we have a data, we should ingest it. So we have to find some way to take this data from the source, transform it, and then put it into the next part that is like a data processing. So data processing actually involves such parts as data visualization, the exploratory data analysis, feature transformation in engineering, etc., etc., etc. So this part is actually pretty crucial for the building machine learning pipelines, because it's like the heart of all the process, all the pipeline. And after the preparing all the features, we are gonna review some models, train those models, and evaluate the accuracy of all the models and select the best one. After that, we have to deploy this pipeline. So we are deploying not only the model, but the whole pipeline. And we have to keep the version in there to be sure that everything works correctly. After that, we have a live system that we should check. And here you can see the feedback loop that should go through all the process. So we have to validate our model, not only on the test data that we have priorly, but we also have to validate it with the real data that we have in our live system. And if everything is okay, we can go ahead. But if not, we have to review previous steps and go back to data processing or model training or model selection step, etc. And if you will take a look on the team that should be involved into this process, first of all, the data ingestion and data processing should be like the process that involves people from different teams. It can be like data engineers and data scientists. Also, model training and model pre-processing can be done by the researchers and data scientists. The next part should be done by machine learning and production engineers. So they have to take the ready pre-trained model and deploy it, and also check the live system. And the feedback loop should also involve machine learning and production engineers. And if other previous steps should be started again, we have to involve other guys again. So what's the problem actually with this? That we have to spread our team into different people with different skills, and it takes time for them to communicate and to work within one team. The next part is that all those steps actually have different problems that we can solve with a lot of technologies. So for example, if we have the data ingestion, we can have different formats like text formats, Parquet format, etc., etc. And we can have also different schemas. We should take care about the data integrity and data security, and data can be taken in real time or batch manner, and everything with this should be taken care, and we have to be sure that everything is okay. The next part is data processing, and it also, as we talked earlier, involves a lot of processes here, and they can be usually solved by different technologies. Usually people take something like Python or R and solve it with scikit-learn or R libraries. Also, if people use deep learning, they take something like TensorFlow Transform, etc., etc. Or it can be solved also with some Spark SQL, or Spark MLLib. The next part is actually the model training and model evaluation. It also can be done with different frameworks and languages. So this problem actually cause a big zoo of technologies, and we have to take care about it. So as a main challenge, you see that we have a lot of bridges to manage in that process of building the big machine learning pipelines. So we have a lot of languages here. We have Python, R, Scala, Java, and other languages. We have a lot of frameworks and dependencies here. Also, we have to take care about the versions of those libraries, and it takes time, actually. Also, another part is performance differences. So as we use different libraries in different languages, they can work in different manner, and it can cause some bottlenecks in this process and cause a lot of problems. Also, another problem is lack of standardization. So it can cause a lot of bicycles because people use different languages and frameworks, and they use different standards, or even something that was just written by themselves. One of the biggest problems is actually frictions between teams, because we have to involve in this process like data engineers, data scientists or researchers, ML and machine learning engineers, software engineers to integrate it with some backend, etc., etc. And also the deployment takes a lot of time, because as we said earlier, that we have to take care about the dependencies and versions. So what is the solution here? To use the Apache Spark for this whole pipeline, and it can just make our life easier and more simple. So this whole pipeline can be written by the data scientist with some skills in Spark, or even data engineers that have some preliminary knowledge in the machine learning area. And all this pipeline can be covered only by Apache Spark. So let's talk about the short intro to Apache Spark. So what is the Apache Spark actually? Apache Spark is just a general purpose cluster computing system, and it was founded in late 2009 and outsourced in 2013 under Apache Foundation. So actually this idea of cluster computing was inspired by the MapReduce idea, which was like the previous version, and was like a father of Apache Spark. And during the developing the Apache Spark, guys from the team tried to cover different problems. First of all, it's iterative algorithms. Next one is interactive data mining. So you can just review and explore big amounts of data just right now and right here. And another one is streaming applications. So what actually Apache Spark proposes? First of all, Apache Spark was written originally in Scala, so it has an API in Scala language. Also, it has like a wrapper in Java, and also provide Python library like a PySpark and Spark R. It means like that we can use even Python or R to write some pipelines. Also, it has like a Apache Spark Core, the package that has all the main abstractions for working with data in distributed manner, and also it has four packages on the top of that Apache Spark Core. First of all, it's Spark SQL to work with structured data. Another one is the Spark streaming that we already mentioned for working with data in a streaming manner. Another one is Spark GraphX to work with the data in the graph representation. And the last one is the Spark MLLib to work with the machine learning algorithms in distributed manner with the big data sets. So the main concept of the Apache Spark is that we have a job to do some transformation with our data sets, and those data sets are distributed between different machines in one that are connected in the single cluster. So we have to split our job into different stages that can be optimized, and they are actually splitted by some rules. And also we have to split those stages into tasks that should be sent to the specific machines and executed on different parts of our data set. So let's start with the Spark MLLib. Actually, after this intro, I'm gonna review some concepts that are present in the Spark MLLib, which is specific package for machine learning pipelines. First of all, let's review what Spark MLLib contains. And first part is that with the help of Spark MLLib, you can use some statistical algorithms and algorithms from linear algebra to explore your data sets and to review some statistical coefficients and statistical analysis on big data sets. Another one is the data preprocessing and feature engineering. So you can just create everything that you need, all the transformation for your data set, all the feature engineering and feature selection stuff. And then you can go to the next step, which is the modeling specifically. And Spark MLLib includes all three main classical algorithms for machine learning, like regression, classification, and clustering. There are a lot of algorithms there, and we can review it later. Another one is collaborative filtering, which is the ALS to make some recommendation systems. Also includes some optimization techniques, frequent pattern mining, model evaluation and selection to evaluate your model and take the best one to work with, and building scalable pipelines. So to review how we can work with MLLib, I've actually took the data set to show the cases in the code and to review how simply we can work with Spark MLLib. So the data set actually is the census data. The main idea of that data set is to classify people, just whether adults' total income exceeds 50K per year or not. So this data set includes 40 features and one label, which is like a binary classification exceeds 50K per year or not. And also this data set, it's pretty big for example, even if you work with the pandas and scikit-learn. So it contains almost 200,000 records in training data set and 100,000 records in test data set. Sorry. So let's start from the data ingestion. As I said previously, Spark actually can work with a lot of file formats. First of all, it's text files. So you can parse your text files in a manner that is actually easier for you. You can work with CSV, JSON. You can work with some even zipped formats like Parquet or C. You can work with data from relational databases with the help of JDBC connector. And even in last versions, you can work with image data just to prepare your images, for example, for some computer vision algorithms. As you can see on the slide, almost all the pipelines start with the creation of the simple Spark session. The Spark session is an abstraction of the like an entry point of all the Spark jobs, and it contains the Spark config, some event listeners adding, and some additional configs. So in that case, we just create the Spark session on the first line of the code. Next, we are trying to read the CSV files from the census income source, and this data is actually without header, so we have to specify our column names. So as you can see, to data frame method takes into account the column names, and the last part is specifying our target column. As it is in the string representation, we have to put it into the numerical representation. So we're going to check whether the income is bigger than 50K or less than 50K, and put it 0 or 1 to have like a double data type column for the prediction. Another part is actually the statistical algorithms and algorithms for the linear algebra, and Spark MLLib contains a lot of algorithms for that. First of all, it's the summary statistics, which includes simple statistics like mean, variance, norm, etc. Also, we can calculate some correlations between columns in our big data sets, for example, like a Pearson or Spearman correlations. We can even test hypotheses in our data sets to check, for example, the significance over our features or anything else. We can also do some sampling on the data set to take some stratified sample from the big data set to work with. And we can also do some dimensionality reduction. For example, if we have a huge data set and we have to compress it, or at least, for example, visualize it in 2D or 3D space. And one more significant part is that Spark MLLib actually works with data in vectors and matrices representation. So MLLib provides a lot of methods to work with vectors and matrices. The next step is actually the data preprocessing and feature extraction. In that case, we have like two main types of those operations. First is transformers, and the next is feature extractors. So the first feature transformers is just some transformation on your features, for example, normalizations, scaling, converting your string columns into numerical values, index them, impute value or values or null values or anything else. The next part, oops, looks like it was reloaded. Yeah. The next part is the feature extractors. They already prepared for doing some specific transformation with your features and taking already vector representation of your columns or records. So it can be like a work2vec to work with some text data, count vectorizers, feature hasher, TF-IDF to work with text too, etc. And in our case, for example, as you can see on the slide, we have some categorical columns and we have numerical columns. So for categorical columns, we have to, as we work with only matrices and vectors, we have to have like a representation of our records to train our models only in numerical representation. And we have to transform those categorical values into numerical representation. So we have our categorical columns there, and we have to change it and transform into indexes or vectors. And in this case, you can see that we are using some string indexers and one-hot encoder estimators to first index our data into like specific categories that that are actually the same as our text, and then we are doing some vector representation of our data in with help of one-hot encoder estimator. Also here you can see the stages array that is actually is done for the next steps for building the pipelines that would involve all those steps, and you don't have to do some manual work. So we are going just to add those steps into array, just one after another, and just run this pipeline on your data set. So you can see that we have string indexer on every column and create the index column. Then we have an encoder that create the classification vector representation. The next part is numerical columns. So we just have to cast them to double type, and already have, as result, we already will have the representation that we need. And the next part, as we already mentioned a lot of times, that Spark ML works with vectors and matrices, we have to make a single vector as a single representation of every record. So we are going to use the vector assembler here, and this vector assembler just like a combiner of all the values into single vector representation. And you can see that we have the input columns. The input columns is just actually this summation of categorical columns in vector representation, and also the numerical columns. And then we have a single output column, which is called features. So as a result, we just have to add this stage assembler as a new stage for our pipeline. Next part is already model training, and in this case, you can see that actually Spark MLLib has a lot of algorithms to work with. First of all, it's classification. So you can see here some logistic regression, some classifiers which are based on trees, decision trees. You can see the linear SVM, naive bias, etc. Actually, we have a lot more algorithms for classifications, but you have to understand that we are working in the distributed manner, so not all the algorithms can be distributed and work on the cluster and on different machines. The next part is regression algorithms. So we have also a lot of algorithms to work with. It's like a simple linear regression, polynomial regression, some decision tree regression, and random forest. Also, we have a gradient boosted trees, survival regressions, etc. And the next main type of the algorithms is clustering. So here we have the LDA, k-means, different types of k-means, like bisecting and streaming k-means, and GMM. So in our case, just to show you the example, I took the logistic regression as like the most simple way to classify our data. And to work with the logistic regression, you just have to create the single object where we put the label column, which is our target column, with the specification of the target, which is like 1 or 0. And the next one is the features column, which was created by our vector assembler. Also, we are adding this logistic regression at the final step of our pipeline. And next part is already the model estimation and model selection. Here, if you're familiar with some techniques for model estimation and selection, you can see that Spark proposes different things for estimation. And first of all, it's train validation split. So you can split your data set into train validation with different proportions. Also, you can do some stratified splits. The next part is evaluators. So it depends on your tasks that you want to execute. You can validate the regression or classification. And in our cases, we have only 2 values, like 1 or 0, bigger, 50, more than 50K or less. It's like a binary classification. And in our case, we are just using the binary classification evaluator. So the evaluator is just an object that includes some metric, takes the metric name, and there are some metrics that we can calculate on that model. And it uses just for evaluating which model is the best from the set of the models that we are trying to train. Also, in Spark ML, you can see there is a grid search, which includes like building a grid of different parameters of our model and doing some tuning of parameters and taking the best model. And cross-validation, which includes like splitting our data set, training data set into several folds, as it called, fold, and then we just change the test fold and take like the best model and take the best hyperparameters here. So in our case, as you can see, we have all the stages here. We are building our pipeline object with the stage which we previously specified. And we have the evaluator here, like a binary classification evaluator with the specifying the row prediction column. Also, we have a parameter grid. So param grid builder is just a builder for different parameters and different options for that. So we have, for example, for logistic regression, we have regression parameter, we have intercept, and we have elastic net parameter and maximum iterations for the model, for the training. So we are just specifying different options, and this param grid builder just make models with all those combinations and take the best one. Then we specify the cross-validator with estimator, evaluator, and put in this param grid that we specify. And we split our data into 5 folds to validate our models. And as a result, we're just doing some simple fit and transform. In that case, we have our data, we have our model trained by the fit method, and transform method will just make predictions on your test data. So if you can, as you can see, it's pretty easy to work with Spark ML, and you just don't have to do everything manually. You just have to specify the steps. And for example, in our case, building ML pipeline contains several steps. First of all, the pipeline have the raw data that we take from the source. Then we have to index our columns, categorical columns. So as a result, we receive indexed columns. We have to use the vector assembler to make a single vector representation of every record, which includes the categorical values and numerical values. And as a result, we will receive the feature vectors. Then we take our logistic regression. So we are specifying some param grid, we specifying some different values for the cross-validation, and as a result, we have the final logistic regression model that we can use. And so every ML pipeline in Spark contains three main steps, which is transformers, estimators, and properties that we specify for the pipeline. And as a result, you can see that pipeline can be built just with 3 lines of code. And this is just super simple in comparison with some libraries that provides like pretty complex syntax and everything that you should do manually. And for example, if you work with the streaming platforms and you have to build the streaming ML solution, it's pretty easy because it's almost the same as we already talked about. So you have the streaming data that you receive in streaming manner. You have to take your historical data snapshot to train your model and split also it into test data set. Then you're building your model and taking the best one. You validate it with the test set, so with the data that wasn't involved into training process, and you just deploy your model. And as a result, the streaming process can use this model to enrich your data or take some inference, and you can already make some insights on your result data. One more additional great feature of the Spark is that actually you can use Spark for building even deep learning pipelines. So for example, Spark can use some integrated libraries, for example, Big DL or Deep Learning 4J or MLLib, which includes some just super simple solution like multi-layer perceptron or SparkNet, but also you can do some integrations with third-party frameworks, which are commonly used nowadays, like TensorFlow, Keras, Kyiv. So Spark usually used in preparing your data for processing, and also it can be used for in tight cooperation with those frameworks. So when you have already your model prepared and pre-trained, you have to use it in your live system. And in that case, you have to save this model as a file on your file system or somewhere in the cloud. And you can do this just with a simple write method. And in this case, Spark will save your pre-trained model in PMML format. So this is like a format similar to XML, and it is used in several more different platforms and different frameworks. So for example, if you have your PMML format model already pre-trained in Spark. You can use it in different platforms like SAS, like a TIBCO, NIME, different solutions for ML from Microsoft and IBM. But one more additional feature here that you can save not only your pre-trained model, but also the whole pipeline that you do with your data to transform and prepare for training and modeling. And in this case, Spark will just save everything into the JSON format, and you can simply read this file in production and do all your transformations and data preparations there with the single file. As about deployment, so deployment is pretty simple, because if everything is already implemented in single Apache Spark, you have to just deploy your Apache Spark code and don't think about the versions here, or don't think how it would work with another parts or another frameworks or even languages. In that case, deployment just involves such steps like pushing your Spark code into your repo, also pushing your pre-trained model. And then you can just put your pre-trained model on your live system server and do some, and take your code from latest code from the repo. But also Spark has some challenges. And first of all, to run everything on Spark, you're for sure dependent on your Spark runtime. So Spark cannot run on the like a single machine without installation. And if you are using it in production, it for sure has to use like solutions like Yarn clusters or Spark in cloud. But still you're dependent on the Spark environment. The next part, the next challenge is that Spark is, as we mentioned earlier, distributed between different machines, and to do some ordering between machines in the cluster and using big or huge, even huge data sets, these scoring models will work pretty slow. And you have to understand that ordering your data will work pretty slow here. The next one is limited numbers of algorithms, and you have to understand that not all the algorithms can be splitted here. So you have to use any algorithm that is already implemented in Spark, or try to write something by yourself. Also, Spark is not suitable for the real time. As we talked, Spark has some Spark streaming package, but this package provides actually not the real time, but near real time in micro-batching manner. And you have to understand, if you want some latency less than like a second, you have to think about some other solutions. And the last one is the PMML format that is used for saving your Spark models, is actually not the conventional one. So for example, some libraries like scikit-learn or other uses pickle formats or other formats which are more used on the market, and more used on between different libraries for machine learning. So if you have already written your Spark, you have to run it somewhere. And first stuff is like cloud solutions. And as we talked, that it's pretty popular here, popular nowadays, and almost all the clouds has some solutions to run Spark code there. For example, AWS has EMR. It has like a AWS Glue to run Spark jobs there. You can set up even EC2 instances in your single cluster. You can use Google Data Prods, you can use Azure HD Insight, or if you don't want to use some cloud solutions, you have to use local mode or Yarn or Mesos clusters set up by yourself. So as a summary, let's go back to the beginning of our presentation and let's review the problems that we had when we use a lot of frameworks and languages there. So first of all, we had a problem that we have to keep in mind that we have a lot of bridges to manage, and this issue is solved by using like a single Spark solution. So we have to keep in mind that we don't have to think about versions, dependencies here, about different standards of code and standards of deploying and writing your jobs. The next one is the lack of standardization, and here as you use only one solution in one language, you can have like one standard for all your pipelines and all your transformation here. So this one is also solved by using the single Spark ML solution. Another one is the friction between teams. But as I talked earlier, that if, for example, data scientists or researchers work with Spark, they can easily write the whole pipeline by themselves, and it can even be done without involving some production engineers or data engineers. So also it can be done by engineers with some knowledge in machine learning. And the last one is deployment. So this part we already discussed, and the deployment is pretty easy if you use the Spark. So it's just a few clicks and a few commands in your shell. So actually that's it. Thank you. Thanks guys for your time.